All right, this video is going to review how to add, subtract, multiply, and divide numbers that are written in scientific notation. So I'm going to start with adding and subtracting. And when you're adding and subtracting, they're already going to have a base of 10, but you want to rewrite them so that they have the same power or the same exponent. It doesn't matter which one of these you change, but you're going to have to either rewrite this one so it's a power of 3, or you're going to have to rewrite this one so that it's a power of 2. So again, it doesn't matter which one, it's just going to kind of vary based on the problem. To me, this one would probably be a little bit easier. So if you've got 3.1 times 10 to the power of 2, this means that it's really like 310. Well, if I, and I want to rewrite it as a power of 3, well, if I move my decimal so that it's right here, this is 0.31 times 10 to the power of 3, because it's still, if you have to, let me change colors. If you move the decimal 1, 2, 3 places, this is now equal to 310. So it's just another way to write it so that it has an exponent of 3. So now when I rewrite it, so this one's going to become 0.31 times 10 to the power of 3. So now that they have the same power, I can add them together. And the reason that they have to have the same power is because if you think about it, when you're adding numbers, you want to add numbers that are in the same place. And the 3.1 times 10 to the power of 2, which is 310, you wouldn't be adding the right places. This is 7,200. Right, 1, 2, 3. So if you just added them the way they are now, you would be adding what's in the hundreds place to what's in the thousands place. So this is why you want to rewrite them so that they have the same power. Now, you also could, and it takes longer, and it definitely depends on your power, you could just write them all the way out in standard form, add them together, and then go back and put your answer in scientific notation. That works as well. But I'm going to stick with this just because sometimes you have really big powers, you know, if it was 10 to the power of 12, this would get really long to start writing out in standard form. So, so now that I have these, I can now say, well, 7.2 plus 0.31, I'm going to add them together. Remember, we line up our decimals when we add. I'm going to fill in my empty places with zeros. So this is 1, 5. So I get 7.51, and since they're both times 10 to the power of 3, my answer is 10 to the power of 3. And so then again, like I was saying before, if you wanted to write them out in standard form and add them together, you could do that. This would be 7,200, and then this one's 310. You add together, you get 7,510, but you have to write it in scientific notation. Put your decimal here, 3 places, so it's 7.51. You can put the 0 or not, it doesn't matter. And then times 10 to the power of 3. Okay. So either way you do it, it doesn't matter. Again, writing it out in standard form first typically takes a lot longer, but it's not that big of a deal. Just as a heads up, if you were to add something that wasn't in correct standard form, meaning that this first number was not between 1 and 10, you would have to then adjust it so that your final answer is written in correct standard form. Okay, so just remember that first number has to be between 1 and 10. All right, so the second example here, again, they do not have the same powers, and I'm subtracting, so I do need to make sure that they have the same power. Let's see. If I make this, so this would be 940 times 10 to the power of 3, right? Because if I move my decimal 2 places, I could take off 2 places and make that a 3. So this is 940 times 10 to the power of 3 minus 7.8 times 10 to the power of 3. Now that they have the same power, I can go ahead and subtract. And the reason I decided to move this one is because this was a bigger number. If I changed this one to a power of 5, I mean, I could do it. It would just become a really small number. But again, it doesn't really matter. It's just personal preference. So now I'm going to have 940 minus 7.8. I am going to fill in my empty places with zeros, and I want to line my decimals up. Remember, 940 is the same thing as 940.0. So I'm going to subtract, and I get 932.2 times 10 to the power of 3. So again, like I was just saying, this first number right here has to be between 1 and 10. And since this isn't, I'm going to fix this. So I'm going to move my decimal 2 places that way. So now I have 9.322. And since I moved it this way, it now has 2 additional places to go. So this is going to change to a 5. So my answer is 9.322 times 10 to the power of 5. Okay. Now, multiplying and dividing is actually pretty easy because all you do is multiply or divide and then follow your exponent rules. So I've got 2.4 and I am multiplying by 1.4. And so when you multiply 2.4 by 1.4, you get 3.36. So these two numbers multiplied together are 3.36. Then I can multiply my powers together. And 10 to the power of 4 times 10 to the power of 2 is 10 to the power of 6. And the reason this works is because order of the numbers doesn't matter when you're multiplying. You could multiply in any order. So that's why you can go ahead and multiply your whole numbers together and then multiply your decimals together. All right, with the next example, dividing, I'm going to go ahead and I'm going to divide these numbers first. I'm a little crazy with my shading. So when you divide 7.56 divided by 1.8, you get 4.2. So when I divide here, I get 4.2. All right, and then I'm going to divide 10 to the power of 5 over 10 to the power of 6. So the exponent rule is that when you're dividing and they have the same base, that you subtract your powers. And 5 minus 6 is -1. So this is going to be 4.2 times 10 to the power of -1.